We now define odds which will be used in logistic regression. So say you have any process. So this process has only two outcomes. Probability of success is P, and therefore the probability of failure is 1 minus P. So odds is defined as a ratio of probability of success over probability of failure. So this is our odds, and this you set as P over 1 minus P. So this is greater than 1 means that P is greater than 1 minus P. So odds greater than 1 means that success is more likely than failure, because in that case P is greater than 1 minus P. Now odds between 0 and 1 means failure is more likely. So that is P over 1 minus P. This is always greater than 0. That is because P is positive and 1 minus P is positive, because P is probability, so it lies between 0 and 1. And we are saying this is less than 1 because probability of success is less than probability of failure. So the odds lie between 0 and 1. In that case, failure is more likely because probability of failure is greater than probability of success. If odds is precisely 1, if you set this equation as equal to 1, P over 1 minus P equals to 1, you can solve this. You will get P equals to half. That is, success and failure are equally likely. So we want a model in which we can compute this odds. So we want a model for odds. But you can see that this model right now what we have is not symmetric. Failure goes between 0 and 1, whereas odds is always greater than 1. So we need to scale this model properly. So as I said before, the success odds, they go from 1 to infinity. It is greater than 1. And failure is always between 0 and 1. So these two are not scaled properly. So we can correct this by just taking the logs of the ratio. So when you have success 1 to infinity, then log of this odds, so this is our odds. So log of odds goes from 0 to infinity. And when odds is between 0 and 1, that is when failure is more likely than success, then log of odds goes from minus infinity to 0. So now you see you have properly scaled them. Success goes from 0 to infinity, failure goes from 0 to negative infinity. So now we have our standard linear model. We always use linear regression. So log of P over 1 minus P, you write it as this, a linear model of x1, x2 all the way to xn, and these are the coefficients which we estimate. So once you do the estimation of a linear model, so this is just a linear model, you can get the odds. So just take exponential of both sides. So exponential and log will cancel out here, exponential here, and then you take exponential here. And that's what you get here, and exponential and log cancel out to get P over 1 minus P. And this is the model which is called logistic model, and it is used to predict probability of success for a model with dichotomous or two outcomes. That is, there are only two outcomes. One outcome is success and the other outcome is failure.